Welcome to the Maricopa County Air Quality Department Annual Emissions Inventory Report training. This is the fourth of 6 training videos that provides an introduction to the General Process Form. The General Process Form is used for all emission-producing processes characterized by the burning or handling of material except evaporative processes. One form reports all of the pollutants for one process. For example, several pollutants are produced during fuel combustion, while only PM10 and PM2.5 are produced when processing rock products or travel on unpaved roads. Similar types of emission sources should be grouped together on a single general process form. As an example, the following general process form on the next slide shows 3 of the same types of generators on the same form. Each of 3 670 horsepower generators grouped together run altogether for a total of 300 combined hours per year. To calculate the annual usage, multiply 670 horsepower, line 2, times 300 hours, line 7, to give 201,000 horsepower hours, line 11, across all 3 generators. An existing general process that is pre-printed on the form from prior years that has been retired can be removed from the report by using a single line strike-through of the listed general process. The general process form has several required fields. The gray boxes next to the data fields are only required when requesting that data be kept confidential and are located where you would mark an X if you're requesting that a particular data element be held confidential. On the general process form, the general process ID is a 3-digit unique ID number that is either pre-printed on the form from prior years or is selected by the individual filling out the report if it is a new general process. Each general process ID can only be used for a single process, and the same ID must be used for the same general process from year to year for consistency. The general process ID number only needs to be unique relative to other general process and evaporative process ID numbers, and can be the same as ID numbers used in the stack, control device, and offsite recycling forms. The process type or description is a general description of the process, but should be specific enough to distinguish it from other general processes. This example has 3 emergency generators, and the specifications are useful in distinguishing them from other generators on site. The stack ID is only required if this process uses a stack identified on the stack form, which is covered in a separate training video. The process tier code is an EPA code that gives a general description of the process. The tier code can be found at the internet links at the bottom of this YouTube video webpage. The SCC code is an 8-digit number that is another EPA code number that is much more specific to the process. Tables for this SCC code can be found on our webpage under Help Sheets. Seasonal throughput percent represents the percentage of time in each season that the process operates. The total for all 4 seasons must add up to 100%. The normal operating schedule describes the typical operation times. In this example, the emergency generator may run at any time during the year, so the hours per day are 24, days per week are 7, and the weeks per year are 52, while the hours per year are the number of hours that the emergency generators actually ran. Typical hours of operation in this example are for emergency generators, and therefore they could come on at any time, so the starting hours are 0000 and the ending hours are 2359 hours. The field for what emissions are based on in this example is horsepower hours, where the 300 hours per year in field 7 is multiplied by the 670 horsepower of the engines in Field 2 to arrive at 201,000 horsepower hours in Field 11. Field 10 describes whether the throughput is in terms of material used or produced, or whether it is an existing value such as vehicle miles traveled or acres of sand and gravel storage piles. Field 11 indicates the annual amount of the material throughput used for the emissions calculations in terms of gallons, hours of operation, horsepower hours, amount of fuel used, vehicle miles traveled, or acres as examples. In this example, it is horsepower hours, which is 201,000 horsepower hours. Fuel sulfur content is the percent contained in combusted fuel oil or diesel. Units of measure describes the annual amount of throughput used for emissions calculations. Unit conversion factor is used if it is needed to convert the units of material throughput to match the units of the emission factors in Field 16. Pollutant is the symbol for the type of pollutant used in the process. In this example, combustion produces all 5 pollutants. Emissions factor is the numerical value that is used to convert the throughput amount after multiplying by a conversion factor if needed into a quantity of pollution prior to any consideration of control device pollution reduction. In this example, the emergency generators ran for 201,000 horsepower hours with an emissions factor of 0.0055 horsepower hours per pound of carbon monoxide to yield 1,106 pounds of carbon monoxide. Emission factor unit per pound should match the annual amount unit of measure in Field 13, and in cases where it does not, the unit conversion factor in Field 14 should be used to convert to matching units. Controlled emission factor field indicates whether the emissions factor has a control device or not. The calculation method code describes how the emission calculations were performed as indicated from the list at the bottom of the form. If you do not have a control device, then fields 20 through 24 can be left blank. Otherwise, fill them out as follows. Capture percent efficiency is the proportion of pollution that is captured by an emissions control device from an output stream. Primary control device ID is the unique ID for this control device from the control device form. Similarly, the secondary control device ID is the unique ID for this control device from the control device form. The control device efficiency describes the percentage of a pollutant removed by the control device from the amount of pollution stream captured by the device. The efficiency reference code gives the method of how the control device efficiency was determined. The estimated actual emissions is the final calculated emissions based on the multiplication of the annual throughput amount in Field 11 by the unit conversion factor in Field 14 and the emissions factor in Field 16, and then accounting for any emission reductions due to a control device in Fields 20 and 23. The estimated actual emissions in Field 25 with no controls or process that use a controlled emissions factor is calculated by multiplying line 11 by line 14 and column 16. If an emission control device is used and there is a controlled emissions factor, then estimated actual emissions in Field 25 is calculated by multiplying line 11 by line 14 and column 16, and then multiplying the result by 1 minus column 20 times column 23. Note that you must use the decimal equivalent instead of percentage for columns 20 and 23. For example, use 0.9612 instead of 96.12%. You may round the calculated emission values in field 25 to the nearest pound. Fields 20 through 24 show the data elements required when a control device is used. Thank you for viewing this Emissions Inventory Report Introductory Training video number 4. Be sure to view the next training video number 5 in the sequence covering the evaporative process and offsite recycling disposal forms. If you have any remaining questions, please call 602-506-6790 or email at emissionsinventory@maricopa.gov. General information and resources for the Emissions Inventory Report can be found at maricopa.gov/2628. Additional information can be found through the internet links listed below this video on the YouTube webpage. Thank you for your participation.